Right. So actually, in the last class, I already show you how to find the derivative of the natural log. Yeah, let's recall the the exponential function first. We know that the derivative of the exponential function is going to be self. Okay. Then if here x replaced by y, okay, then x and y are different. So y is you can view y as a function of x, right? Then by the chain rule, we still have the same function here. Then dy dx. This is a slightly more general identity. Okay. Okay, we needed that, right? Then we know that we have to define the inverse function, right? If y equals e to the x, if you solve for x, you get natural log 1. Okay. Then using this, you can get the inverse function, right? So this will be, it's not equality here, and I interchange the variable, right? Then interchange the variable, then I get an equation for the new function, which is called the natural log. Okay, since it's this is inverse to each other, so you have two identities. E to the natural log of x is going to be x, okay, and then another one is e to the natural log e to the x is going to be x. Okay, now I'm going to use the first one, the one on the left, to find the derivative. Okay, so differentiate both sides with respect to x. Be careful, right? So remember, yeah, this is a formula we can use, right? So here y is the natural log x. So this is going to be e to the natural log x times derivative of natural log of x with respect to x. The right-hand side is just 1, okay. Right? But e to the natural x is nothing but x. This is x, right? So it's x times the derivative of natural log x is going to be 1. So now I get to the derivative of natural x equal to 1 of x, which is also can be written as x to the negative 1. This is a very interesting identity. Okay. So here x must be positive, clearly, right? X must be positive. X must be positive. Yeah. So, but the natural log of x is only defined for positive x. Okay. So the graph looks like that, right? And this is y equals natural log of x. Now, how to draw the graph y equals natural log of absolute x? Clearly, this is defined for x not equal to 0. And when x equals positive, then this is just equal to natural log of x. Okay. When x equals negative, when x is negative, so actually this piece also. Okay. So absolute of x is going to be x if x is positive, right? Negative x if x is negative. So the graph of natural log of absolute of x, this derivative. Yeah, we want to find the derivative. Okay, so for x negative, right? Okay, I'm going to find the derivative of natural log of absolute of x. Okay, I want to see what is that. Okay. Yeah, I'll talk about the quiz problem later. Okay. So for x less than 0, this is going to be the derivative of natural log of negative x because x is negative, right? So by the chain rule, right? So this is going to be First is going to be 1 over negative x, then derivative of, okay? The chain rule says that. Remember, derivative of x, natural log of y, is going to be 1 over y, then dy over dx. Okay, that's the addition term here. Okay, so, but that is going to be -1, right? The derivative. So it's after simplifying, it is 1 over x. Of course, it's negative, but you don't see the negative sign. You don't see the negative sign. Okay, so when x is positive, I have the sum. The derivative is 1 over x. When x is negative, the derivative is also 1 over x. So I get the formula. This is a true for x not equal to 0. That's it. It's not necessary to be x. Yeah, x could be negative, could be positive. All right. So this also tells you that the integral of x, the antiderivative of x to -1, is nothing but absolute natural log absolute x plus constant. Okay, this by the above formula, right? All right. Now recall the x to the n, right? The antiderivative. And you will see that that formula says that's 1 over x, 1 over n plus 1 x to the n plus 1 plus constant. But remember, n plus 1 cannot be 0. Then what happens when n plus 1 equals 0? That means when n equals 1, and n equals 1 is the antiderivative will be natural log over 3x. Right? So it's now we cover we get the antiderivative x to the n for any n. N could be equal to -1 or not equal to -1. If it's equal to -1, the antiderivative is a natural log of absolute x. Right? If n plus 1 is not equal to 0, just it will be 1 over n plus 1 times x to the n plus 1. Right. So this is about the derivative and its integral, and the integral about related to natural log function. Okay. All right, let's do some. Let's evaluate some integrals. Evaluate 2x plus 1 dx. Okay. Well, this is similar to the integral of 1 over x, but slightly different. You have 2x plus 1 there. So what they do is use a substitution, that u to be 2x plus 1. Then du equals 2 dx. Okay. So the denominator is just 1 over u. Now dx, from here you can solve for that. That's 1/2 of du. Okay. Then you use our formula. The integral of 1 over u with respect to u is going to be absolute over u plus constant. Okay. Right. So then you replace the u by 2x plus 1. Okay. So let's look at this problem again. You will see the function in the integral is 1 over 2x plus 1. So it's pretty similar to the function 1 over x, right? But it's not going to be just, then you cannot apply the formula directly. This is our formula, right? This is our formula, right? You cannot apply that formula directly. So because the formula says that here's the x, 1 over x times dx, but this one is 1 over 2x plus 1 times dx. So you cannot apply that formula directly. You have to use substitutions to simplify the integral until you get this one. Then you can apply the above formula. Okay. And then at the end, you have to still express it as a function of x. Okay. All right, let's try a slightly different one. Here's x over x squared. Okay, similarly, this is yeah, this function is complicated. We have to choose the right substitution to simplify. Okay, and there is no general rule to set up right substitution to find the right substitution. You can try and this and that, and gradually build up experience. You can quickly find the right substitution. So for this one, I think I'm going to let u to be x squared plus 1. Okay, then du equals 2x dx. I quickly do the computation. So I say, okay, that's 2x dx and x dx, right? So that's all we need. That's the integral of u. X times dx is half of du, okay? Okay, then it's 1/2 natural log absolute of u plus constant. Then you replace u by x squared plus 1, okay? And plus constant. And in this case, you see that x, this is true for any x because x squared plus 1 never be negative, right? It's always greater than 1. So it's always defined. All right, so let's go back to that. Let's look at an arbitrary log function with a base, A, okay? Why we have to focus on the natural log x? Because any function, any log function with base A is actually going to be natural log x divided by natural log a. So it's just the natural log x times a constant or divided by constant. Okay. Therefore, when you differentiate, there is a derivative. You just need to find the derivative of the natural log, right? So which is going to be 1 of x, then natural log. Okay, so this is a very general formula. Okay, so if you have to find the derivative of like log of x was base 2, then that's going to be x natural log of 2. Right. So the derivative, you always get a natural log, right? And then the derivative of 2 to the x, right? Is going to be 2 to the x natural log of 2, but this natural log of 2, 2 to the x multiplied by natural log of 2. Right. Right. So now let's find some derivatives. Okay, y is going to be natural log absolute of x squared plus 1. Find the derivative y with respect to x. Okay, you think about that. What is the best way to solve the problem? Okay, I'll give you half a minute to think of. Okay. All right, so some of you tried, right? It looks like this is a problem you have to use a channel, but that's still tricky here because it's difficult to find out the derivative of square root x squared plus 1. So there's two different ways to solve the problem. The first one you can try, okay, use a chain rule. It's going to be, right? Then you have to find out the derivative of x plus 1. If you do this way, and you have to face a problem, another chain rule, right? It's 2 square root x squared plus 1. You can do that. It's not a big. And yeah, how can I do, right? And this is a, like a x squared plus 1 to the 1/2. So you have to go 1/2 and x squared plus 1, 1/2 minus 1. Then you differentiate inside, it's going to be 2x, right? So step by step. And and then you get 1/2, and this become 1 over square x squared plus 1. So actually combine with the one front, then you get this. Right, finally, 2 cancel out, you get x over x squared plus 1. Right. I prefer the following. Okay, you should simplify it. Yeah, this is a. Sorry, I don't need a parenthesis here. What I was trying to do is actually to express it in this form. Then I take 1/2 out. There's no radical at all. There's no radical. Then if you differentiate, you will get, then you apply the chain rule here, it's 1 over x squared plus 1, and then derivative of x squared plus 1 in the product, right? So that would be 2x. So you get 1/2, and here's 2x. 2x is canceled out. Then what do you get? You get the same answer, but it's much easier. Okay, so when you see a radical inside of natural log, try to simplify this. First, simplify the function first before you find the derivative. Okay, similar problem is to the following one. Okay, I still want you to try first. Okay, and find the derivative of this function. Okay. Right, any idea? Okay, so I hope you get the answer, okay? So the idea is here, see, look at this is a fraction, right? So it's not easy to differentiate a fraction. You have to use a chain quotient rule. So what I'm going to do is I express it as a difference of two natural log functions. Then you differentiate each of them, like this one. You get the 1 over x plus 1, and the derivative of x plus 1, right? That's easy. And then another one is 1 over x minus 1, the derivative of x minus 1. And that is just only 1, right? And here's 1 over x. So that's it. This is the answer. So you can combine them if you want. If you combine them, and you will get negative 2 over x plus 1 and x minus 1. So x minus 1 minus x plus 1 will be negative 2. Right. You can try this also. Okay. Yeah, please. Yeah, this is, I'm going to show to you. Okay, so y equals 4 natural log of x plus 1, right? Then it'll be much easier. So the derivative of y equals 4. Then when x squared plus 1 should go to the denominator. Then you have to differentiate x squared plus 1. Okay. So the derivative of x squared plus 1 will be 2x. And I have a 4 here, x squared plus 1. So after you simplify it, you will get, right? You will get x, yes. Now, there are some functions does not look like, there's no radical inside. Okay, no. You don't see natural log. Okay, so can we quickly find the derivative of this function? You have to apply the quotient rule, right? You have to use a chain rule to solve this problem. It seems to be, it's pretty complicated. Honestly. Is there any better way to solve this problem? Right? All right, so I'm going to show you the, I do not see natural log there, right? But I can put natural log. Okay, then the one on the right hand side, you have 1/2 natural log of x squared plus x over x squared minus 1. But that's not good enough. You can separate this. Okay, then I differentiate both sides with respect to y, and with respect to x. Okay, so the derivative with respect to x, this is going to be 1 over y dy over dx, right? And this one will be 1 over x squared plus x. Then derivative of the new x squared plus x will be 2x plus 1. And here's x, 1 over x squared minus 1, and then be 2x. Okay. Then in order to find the derivative, I just multiply both sides by y. Okay, but I already know the y. Y is the square of x squared plus x over x squared minus 1. Right, so that's it. See, maybe not necessary to simplify, but this is how do we quickly find the derivative without making mistakes. Yeah, you have to borrow the natural log, so you can decompose the original complicated function. Okay. This problem is different from the previous problem. Previous one, we already see the natural log there, and then use a formula for the natural log. You can decompose a function into several pieces. Each of them is easy, so linearly, right? So you can differentiate one of them or each of them, right? And a similar problem will be the next one. I want, okay, find the derivative, okay? I ask you to do it, okay? You should able to finish it. Yeah, please do it. Right? This is pretty similar to the previous problem, right? We have to use a natural log to decompose this function, right? So it's similar. You put a natural log, okay? So this is just the x minus 1, x plus 1, right? To the 1/3, the third root of this. Okay? Then the continue you will get. All right. Then it's easy to find the derivative. The left-hand side, when you differentiate with respect to y, or with respect to x, you have the derivative y with respect to x, okay? And here, the derivative of a natural log of x minus 1 will be 1 over x minus 1. Here's 1 over x plus 1. And now you can simplify. I think you can simplify. And that will be 2. Okay, derivative y with respect to x will be just y. Y is going to be x minus 1, x plus 1 to the 1/3. I think we should further simplify. X minus 1, here's x minus 1 to the 1/3, right? So it will be x minus 1 to the 1 minus 1/3, 2/3. And x plus 1 will be 1/3 plus 1 is 4/3. So that is that. Okay. All right, now let's take a look at the trivial, let's look at this integral. Then say, well, yeah, that's easy, right? Okay. So first of all, this is so evaluate the integral, right? F of x is going to be nothing but natural log of t, evaluate the two endpoints. So natural log of x minus natural log of 1, which is just natural log of x. because this is nothing but natural x. Then you say, wow, then I can use this one to define natural log x using integral. I don't even go through the exponential function, right? I know the natural log is defined to be inverse function of the exponential function. Well, look at this definition. It's not very natural, okay? It's not a natural definition, okay? Not a natural definition. Okay? Natural log x. As long as you understand the integral, right? You can use the integral to define the natural log x. Why it's not? You can define it in this way. Then you have to eventually have to show that this is going to be the inverse function to the. This have to be inverse function to the exponential function. Right? We define the natural log function to be the exponential, the inverse to the exponential first, exponential function. Then we derive this formula, right? And but you can also use this one as a equivalent definition. Okay. And if you use this one as a defined, you see, it's harder to define the exponential function. It's harder to define the logarithm function, right? But you can use the elementary function you're familiar with, 1 over e to the x, and then use the integral to define natural log. Okay, once you define the natural log, then you can define its inverse, which is the exponential function. Can you see that? But this is so it depends on which ones you give the definition first. And then you get many equivalent formulas. You can use any one of them to define the same thing. Okay. So different authors maybe use a different, begin with different definitions of the same function, exponential function or logarithm function. Yes.
Dr. Shen, question for you. On the natural log of x minus the natural log of 1, why is natural log x positive and not negative?
Natural log of x, so x must be positive. X must be positive, in the, what's your question? Because in the original definition of natural log of x, which should be the inverse function. The inverse function, if from the inverse function, you can see that natural log only takes positive value. Okay, so that's why, yeah. So we call, y equals e to the x, right? That's only, So here y is positive, x can be any, right?
Yes.
It can be any number, okay? Then you solve for that. You see, this y is positive. Okay, so whatever, inside the natural log, this should be positive. Okay.
Yes, okay. Thank you.
Right. Just because from the definition of the natural log. Okay, so then the domain of the natural log will be the range of the exponential function. Okay. So you can say that domain of natural log of x is going to be is going to be the range of the exponential function, which is going to be near to infinity. Okay. Yeah, just be careful a little bit. Now let's take a look at a very strange function. X to the x. This is really strange. Now, what do we know? Okay, what we know is there are two formulas, right? A to the x is a to the x natural log of a, right? We know that. We also know that the derivative of x to the a is a times x to the a minus 1. Okay, but at least one of them is a fixed constant. can we use this to find the derivative of y with respect to x? Okay, and here at the base and the power both changes. Now, if you took calculus before, you may be familiar with this problem. I don't think you're still able to solve it because otherwise you already passed this course, that course, you don't need to retake it. Okay. All right, so try to find a way to find the derivative. Right, so we cannot apply the formula directly to this problem. So in other words, the derivative of, x to the x is not going to be x to the x, the natural log x, okay? Because there's no such formula. If you want to use the first formula, it's not going to be x times x to the x minus 1 if we want to use the second formula. All right, they're different. So how can I find the derivative? Well, use the same idea. Let's put the natural log on both sides. Okay, then the right-hand side is going to be x. This x can be moved. Okay, so this will be a product of two functions. Okay, so when you differentiate both sides with respect to x, the left-hand side use a chain rule. 1 over y, dy over dx. The right-hand side, you apply the product rule. So it's 1 times natural log x plus x times 1 over x. Okay, so that is 1. So x is natural log x plus 1. We're almost done, very quick. It's y times natural log x plus 1. So what is y? Y is just x to the x. Okay, let's stop here for a minute, for a second. So we see the same trick, right? You put a natural log on both sides, and so you decompose that function. X to the x is a very bad function. Now it becomes a nice function, just a product of two functions, x times natural log x. You can apply the product rule to find the derivative. Okay, every step you go, you have to follow the algebraic rules, right? You have to follow the algebraic rules. Right? If you cannot create your own rule. You cannot create your own rules, otherwise you're going to make mistakes. Okay, so mathematics, mathematicians don't create rules. Right, that's already given by the God. Right, we're just trying to understand. Of course, we create a notation, symbols to describe it. Okay, but we're not going to change it. Okay, you understand? So if you make up your own rules or use the wrong rules, then you end up with the wrong answers. Okay, so now this is the answer, right? Is there any slight different ways to solve the problem? Yes. And I can change this to this e to the natural log of x to the x, right? And then I can get e to the natural log of x. So this is a, well, just an exponential function, okay? So I can also solve this. When you differentiate by chain rule, you have the derivative of x times natural x, right? And the first one is still x, go back to x to x. The second one here is a product, 1 times natural x plus x times 1 of x. Right? So derivative of natural log is 1 of x. So this is a product rule, right? Product rule. Okay, we have to follow the rules, right? To derive the formula. Right. Right. So there's a slightly different way to do. And let me take a look at another problem. So this is implicit differentiation, okay? If x to the y is going to be y to the x. Find the dy over dx. It's a derivative of y with respect to x. Now, this relationship is weird, very weird, okay? X to the y is going to be y to the x, okay? Can you solve for y in terms of x? Nah, at least I cannot express it using elementary function. So they're just bonded together. So like a, right? They're bonded together. It cannot be separate. Right? But those are the relationship, right? This is a relationship between those two variables. One variable changes, other variable probably can be uniquely determined. Okay? For example, when x equals 2, what is the y value? When x equals 2, what is the y value, right? Okay, 2 to the y should be equal to y squared. What is y? Now, can you tell that? No. Okay, it's harder to tell what is y. Right, and I guess y should be 2 because that's a unique solution. We have 2 squared equals 2. We are lucky, this time we can find the y. When the input, when x equals 2, y is 2. Okay, when x equals 1, maybe y is 1. Yeah. Okay. But in general, you cannot express y in terms of x. How can you find the derivative? Just chain rule. Okay. Just chain rule. So derivative of this with respect to x. Okay, with respect to x, we use a power rule. We call it power rule to the one on the left-hand side. So that is going to be y, x to the y minus 1, and the derivative of, no, we cannot use this, okay? Think about that. Y is a function of x, right? Y is a function of x. Y is a function of x. Are you able to differentiate this? You see, when you, think about that. This is a place you may have to make mistakes, So dx x to the y, okay, that's not going to be, because y is also a function of x, it's not a constant. So it's not going to be y times, And then you say, okay, how about I can put a dy with dx? That's wrong. There's no such formula there because the first part is wrong. Okay. The first part is wrong. Okay, you cannot view y as a constant. So you cannot apply the power rule to this problem. Okay, because y and x are related. So it's difficult. What you can do is you still put the natural log on both sides, and they get a y natural log x. And here's x natural log y. All right, each of them is a function of x. So you can do each factor. Then you can differentiate with respect to x. So you can apply the product rule, right? And this is a product rule. And the right-hand side is 1 times natural log y plus x. Okay. All right. So now find 2 terms containing the derivative. So I have it. Okay. And this term should be go to the right-hand side. So that's it. Right. So now you can solve for the derivative. Okay. It's pretty symmetric, x and y and x. If you interchange the two variables, you end up with similar equations. So the derivative is going to be natural log of y minus y of x, natural log x minus x of y. Okay. So that's all we get. Again, let me explain to you why x to the y is not going to be y x to the y minus 1 dy dx. Okay. So let's use a chain rule. Okay. The chain rule says that and that's a chain rule. But when you differentiate this with respect x to the y, right? That's a derivative with respect to y. But x is not an independent function. X is going to be x depends on the y variable. Okay, x depends on y variable. So I cannot apply the formula to the problem to this derivative, okay, because x is not a constant. All right. So every step you go, you have to think about what algebraic rule you can use. All right. So let's take a look at the problem from the book. So we have a function. All right. Find the value b such that f prime 1 equal to 3. So what is that question? The b is undetermined. And I want to find the b modified as parameter so that the derivative of the function evaluated to 1 is going to be 3. So what I'm going to do is I just find the derivative first. Then I solve the equation, okay? So find the derivative. What is the derivative of this? Well, This function can be written in the form natural log of b, natural log of 3x squared minus 2. All I have to do is find the derivative of natural log of 3x squared. Yeah, minus 2. Okay, so that is going to be the derivative of 3x squared minus 2. Then you differentiate and numerate. It will be 6x. Okay. Yeah, because why you got 6x? Because the derivative of 3x squared is going to be 6x. All right, so then I evaluate. I get a 1 and 3 minus 2 natural log of b is going to be 6 natural log of b. All right. So this is supposed to be equal to 3. So in other words, natural log of b should be equal to 2. Then b should be equal to 2 squared, e to e squared. E squared. All right, there are a few integrals. This is also from the book. Yeah, please work on this problem. Yeah, please try your best to evaluate this integral. Right, so I hope you already done. So let's try. Look at this, right? Natural log of x square over x. So I don't like the natural log inside integral. Right, so it's very natural to let u to be natural log x. So du equals 1 over x. Great. So that is going to be u squared x over dx is just the du. Okay, so that's going to be 1/3 u cubed plus c, and u is going to be natural log of x. All right. Yeah, I'm going to talk about the quiz, okay, later on. Okay, don't worry. Okay. Yeah, you're pretty anxious about the first quiz, right? Okay. All right. So let's take a look at this. This is the last problem I want to discuss. Okay. So substitution, you let u to be 2 plus sine x, not cosine x. Okay. Then du equals cosine x dx. Okay. Therefore, therefore, this will be 1 over u and du, and then it will be natural log u plus, I will put the absolute value here, and the plus constant. Later on, probably I have to remove the absolute value because this is a 1. If I put the 1/2, then I have to put absolute value there. Okay, so that is answer. Okay, that is answer. Now,